Hello everyone, good morning. I'm going to make another video. This is on assignment 11.1 practice and specifically exercise 11.03 by request. So here we're actually computing a chi-squared test for variance, a single sample. They give us the alternative and null hypothesis already, but what they don't give us in this case is the data. So we can't just plug it into data analysis toolpack and push the button and have it give us the test statistic and the p-value. So we're going to have to do these computations another way. And so we're going to use the formulas. Now, the first thing that I'm going to do is use Excel, even though I'm not using the tools in Excel. I'm basically using Excel as my calculator here. And so the first I'm going to start by putting the inputs, the n, the sample size. And for me, that's 16. And then I'm going to put in the variance. So this is the sample variance. I'll call it S squared. And that's the variance from the sample. And they tell us the sample standard deviation is 9.5. And so the variance is going to be the square of the standard deviation. So I'm going to just do here equals 9.5 quantity squared to get the variance here instead of the standard deviation. All right, 90.25. And then I'm going to plug in the presumed variance of the population, which is the sigma squared, which is the what we're comparing against the 50 in this case. And that's already the variance because it's sigma squared. So I'm going to put the sigma squared, and I'll put in the 50. All right, so now I'm going to compute the chi-squared statistic, the test statistic, chi-squared. And the formula for that is n minus 1 times s squared divided by sigma squared. I'm going to do equals parentheses n minus 1 times s squared and then divided by sigma squared. Right, so that gives me the chi-squared of 27.075 to 2 decimal places. And you can use this tool if you want to actually do the rounding instead of that round feature in Excel, 27.08. All right, now next we're going to find the p-value, the low and the high end, but they want us to actually use this from the table. I'm going to pop open this table and kind of look at this area in the upper tail and the degrees of freedom. All right, so give me just 1 second. Okay. So what we're going to do is look at, first of all, the degrees of freedom, which is n minus 1. So remember our n was 16, so our degrees of freedom, n minus 1, is 15. Right, so I'm going to go to row 15 under the degrees of freedom, and I'm going to scan across, and I'm looking for that chi-squared number in this chart, the chi-squared number being 27.08. So under 15 degrees of freedom, 27.08 falls between these two values. So the low end is 0.05 and the high end is 0.025. So it's somewhere between 0.05 and 0.025. So the low end is 0.025 and the high end is 0.05. Okay, and now we're going to find the kind of critical value, this chi-squared at the 0.05 level, and find the value that would be that cutoff value, so we can compare our test statistic to that cutoff value. So again, I'm going to look at this table. I'm looking for 15 degrees of freedom and a 0.05 upper cutoff, right? So 15 degrees of freedom and a 5% upper tail. So the critical value here is going to be 24.996. All right, and now we're going to make a rejection decision. So we're going to reject the null hypothesis if the observed chi-squared value, 27.08, is bigger than or equal to 24.996, which it is. And so in this case, we are going to reject the null hypothesis. All right, so that's how you do 11.03 under assignment 11.1 practice. If you'd like some more videos like this, please just ask. This particular request came in by email. That works great, and I'll pump these out as quickly as I can. Thank you. Have a great day.